Let's cover sequences. So let's start off with a sequence that says an and is equal to 3n plus 2. If you want to know the first four terms of this sequence, you start off by the first term, which is a1. So a1 is equal to 3 times 1 plus 2. Everywhere you see an n, you replace it with the 1. So that'll be 3 plus 2, which will be 5. Okay, a2. a2, you simply replace all the n's with a 2, so it'll be 3 times 2 plus 2, which will be 6 plus 2, which will come out to 8. So a2 will be 8. a3, if you try to calculate a3, a3 will be 3 times 3 plus 2, which would be 9 plus 2, which comes out to 11. a4, let's see if we can figure out a4 without using the formula. All of this will always be a pattern. If you look, the first a is 5, the second a, which is a2, is 8, and the third a3 is 11. If you notice, it's a pattern and they're jumping by 3s. So essentially a4 will jump by 3, so it will be 14. Okay, let's look at an. The sequence an equals negative 1 to the n plus 1 power divided by 2 to the power of n minus 1. And the first four terms of this sequence, and see if we can figure a pattern out. Well, a1 will be negative 1 to the power of 1 plus 1 divided by 2 to the power of 1 minus 1. Because everywhere you see an n, you replace it with a 1. So this would be negative 1 to the second power over 2 to the 0 power. Negative 1 to the second is negative 1 times negative 1. So that will essentially be just 1. 2 to the 0 is just 1. Anything to the 0 power is 1. So a1 comes out to 1. Okay, a2. Everywhere you see a 2, you replace it, the n's with a 2. So you have negative 1 to the power of 2 plus 1 over 2 to the power of 2 minus 1. Okay, that's negative 1 to the third power over 2 to the first, because 2 minus 1 is 1. Negative 1 to the third is negative 1 times negative 1 times negative 1. That will essentially be negative 1. 2 to the first is 2, so this becomes negative 1 over 2, or negative 1 half. a3, everywhere you see an n, you replace it with a 3, so you have negative 1 to the 3 plus 1 divided by 2 to the power of 3 minus 1. Negative 1 to the 3 plus 1 is negative 1 to the fourth power. And 2 to the 3 minus 1, 3 minus 1 is 2, so this would be 2 to the second. Negative 1 to the fourth is negative 1 times negative 1 4 times. Any even number of negatives you multiply will always be positive. So this will come out to positive 1. And 2 squared will be 4. So looking at the pattern, let's see if we can figure out a4. If you look at it, a1, the numerator is 1. a2, the numerator is negative 1. And a3, the numerator is 1. So these numerators are alternating. 1, negative 1, 1. So a4 will be negative 1. If we look at the denominators, this denominator, if you look here, is 2 to the 0. This one is 2 to the first. And this one is 2 to the second. So essentially, the a4's denominator would be 2 to the third. So the answer would be negative 1 over 8, because 2 to the third is 8. Now let's look at a recurrence sequence. So recurrence sequence, in order to find, for example, a5, you need to know what a4 is. So whatever a you're looking for, you have to already know the a before it. So let's start off by a1 being 7. And let's say an will be equal to a subscript n minus 1 plus 5. Okay, we need to find the first four terms of this sequence. So let's go with the first 5. So since we're already given a1, let's start with a2. So a2, everywhere you see n, you plug in 2. So it'll be a subscript 2 minus 1 plus 5. 2 minus 1, that's a1. because 2 minus 1 is 1 plus 5. Well, what is A1? We were given A1 at the very beginning. A1 is 7, so this is 7 plus 5. So A2 is 12. Let's say we're trying to find A3. So A3, everywhere we see n, we put in a 3. So it'll be A 3 minus 1 plus 5. And 3 minus 1 is 2, so this would be A2 plus 5. What is A2? A2 is what we found in the previous step, which is 12. So when we plug it in, we'll have 12 plus 5, which comes out to 17. So if you see the pattern, let's see if we can figure out A4. Looking at A3, it's the same calculation plus 5. So it's the previous one plus 5. Looking at A2, it's the previous one, which is A7 plus 5. So A4 will be the previous one, which is A3, which will be 17 plus 5, which will give us 22. So A4 is 22. Let's say we have a problem that says 17 factorial divided by 15 factorial. I know some of you are wondering what a factorial is. Well, let's go through this little mini lesson. 4 factorial, for example, is 4 times 3 times 2 times 1, which will be 12 times 2, multiplying everything 2 at a time, 24 times 1, which comes out to 24. So 17 factorial will be 17 times 16 times 15 all the way down to 1. So factorial is essentially a big number. So let's say we had 100 factorial. That's a really huge number. And let's say we didn't want to list it all the way out. So we can go 100 times 99 times 98. And let's say I didn't want to go anymore. If you want to stop anywhere in the middle, you just put a factorial on the end. So 98 factorial is 98 times 97 times 96 all the way down to 1. So that's the little mini history, a mini lesson over factorials. So if we have a problem that says 17 factorial divided by 15 factorial, well, 17 factorial is 17 times 16 times 15. If I want to stop here, I just put a factorial at the end, and that's divided by 15 factorial. So if you look at the numerator and the denominator, they each have a 15 factorial. So what I can do is cross those out, and I'll just have 17 times 16, which will give me 272. Let's say we have a summation. So let's say we have the summation of k that goes from 1 to 5 of k multiplied k plus 1. So this summation, or what some might know it as a sigma, stands for add up. The bottom number under it tells you where to start. The number on the top tells you where to stop. And everything to the right of it is the actual formula that you will be plugging the numbers in. So this summation says k goes from 1 to 5. So it starts at 1 and ends at 5. So when you plug it in, when k is 1, you have 1 plus 1, parentheses. Then you go when k is 2, 2, parentheses, 2 plus 1, because you're replacing the k's with a 1, 2, 3, 4, and a 5. So the next one will be when k is 3, which is 3, open parentheses, 3 plus 1. Then when k is 4, which is 4, open parentheses, 4 plus 1. And lastly, when k is 5, which is 5, open parentheses, 5 plus 1. Now, if it's no number at the top, that means it goes to infinity, which is something that you don't want to do by hand. So normally it's a number at the top when you're actually doing this by hand. So when you calculate it all out, this is a 2, and you multiply it times 1, so that'll give you 2. This is a 3 that you multiply times 2, which will give you 6. This is a 4 that you multiply times 3, which will give you 12. This one is a 5 times 4, which gives you 20. And this is 6 times 5, which gives you 30. So when you add them up in twos if you're doing it by hand. So this would be 8 plus 12 plus 30 plus 20. 8 plus 12 will give you 20. So this is 20 plus 30 plus 20. Remember, when you add up, you do it 2 at a time. So 20 plus 30 is 50 plus 20. And that essentially comes out to 70. So the summation from k from 1 to 5 of k open parentheses k plus 1 is equal to 70.